Hello everyone, I'm Kurt Feldman, the Director of Engineering at LS-Energy Solutions. We're a North American-based organization that focuses on energy storage. I'm here today to talk real quick about who LS-Energy Solutions is and to present you some new and exciting products that we'll be launching in the next few months. It's an energy storage inverter that has very unique and innovative designs that we think will be very competitive in the market. We're calling it the LS-BRic. So who is LS-Energy Solutions? About 2 years ago, LS-Electric acquired Parker Hannifin's energy grid tie division. We became part of the LS family, and a new North American organization was formed called LS-Energy Solutions. Our main focus is energy storage. We are historically inverter experts, but have done a lot of integration and complete solutions as well. Over 40 years ago, we originally started as AC and DC drive experts. We have a long experience in power electronics. We are considered pioneers in energy storage, and we were part of installing the very first commercial lithium-ion storage system in the United States back in 2008. To date, we have installed more than 900 megawatts and over 250 different systems on the grid. I will now talk about our new and innovative energy storage inverter, the LS-BRic. It has a very unique design and several advantages that we believe will be setting us apart in the market. Instead of designing a large central inverter that is not very flexible for the customer, our approach is a building block type approach that allows the customer to customize to meet their needs. When we started out the development effort together with LS-Electric, we decided on some key design criteria. First of all, we wanted it to be easy for customers to integrate into a final solution. Also, with new battery technology, we needed it to be able to operate up to 1500 volts DC. Cost compression in the market is very real, and we needed this inverter to be cost effective, both in terms of manufacturability and also in terms of overall implementation costs by the customer. It also needed to be very efficient. Our customer requirement is more than 98%. We also needed it to have many of the certifications required for shipments around the world. For example, UL 1741SA, CE, AS4777. So when evaluating different design options, we also made the decision to do it as a 3-level neutral point clamping design. This made a lot of the design criteria much easier to meet. The outcome of the design effort was very successful, and we have a number of different advantages that we can emphasize when working with our customers. First of all, it's very powerful and flexible. It has a lot of power in a relatively small package. It's designed to fit into a standard 19-inch server rack, and it only takes up 7U of height. For an inverter that is rated up to 200 kV at 690 volts AC, this means that it can be easily integrated into a rack solution, either the same rack as the batteries or in a separate rack by itself. For customer flexibility, it comes in 3 different voltage ranges: 480 volts, 600 volts, and 690 volts. But since building the exact same from a hardware standpoint, they can all operate on the DC side of up to 1500 volts DC. The unique aspects of the design is that the inverter can be paralleled up to whatever power rating you need on the AC side, which is up to 16 inverters, and can also be paralleled on the DC side. This way the customer can decide on how many separate DC buses they would want. This also helps optimize the power ratings for both energy and power. Also, with a very wide temperature range, it can operate in environments up to 55 degrees C. Another very important aspect of the LS-BRic is that it has enhanced safety for the customer. It comes equipped with automotive-style touch-safe power connectors. Another unique and important advantage of the inverter is its ability to be flexible in terms of the number of DC buses. This allows us to keep the DC short circuit current ratings very low. Another advantage of this is that the system can be designed using more readily available and cheaper DC protection devices. Another important aspect of the LS-BRic is that it improves operation for the customer. In a system with several LS-BRic inverters, if one inverter were to go down, the system will continue to operate but at a derated power level. Also, since they are comparatively small, it's very easy to keep a spare LS-BRic on site, which can allow for the inverter to be swapped by a local technician so that the customer can keep the system and get it back up and running relatively quickly. The fact that the inverter is made up of small building blocks allows the customer to parallel the inverter up to the correct size. This way, the perfect size can be created and there's no need to oversize. Along with the other powerful advantages of the LS-BRic, it can be used in almost all of the energy storage applications. It has the ability to do both grid following and grid forming, which makes it perfect for use in both behind the meter as well as in front of the meter applications. To mention a few, it can do backup power, black start, frequency regulation, ancillary services, peak shaving, solar plus storage, and many more. So, how does this scalable inverter approach really work? Well, as I mentioned before, the LS-BRic can be paralleled up to 16 inverters. Based on your battery configuration and energy needs, you would then select the number of DC buses to properly match your energy configuration and your short circuit current requirements. You then can integrate into your preferred enclosure design, whether that's an indoor or outdoor application or in the same enclosure as the batteries. This gives you total flexibility in your design approach. The LS-BRic comes with a separate master controller. You would need one master controller per 16 inverters or one master controller per DC bus. The master controller fits in that same 19-inch rack configuration as well as the inverter. The master controller provides the advanced functionality for the system. There are additional advantages with the LS-BRic scalable inverter approach. The master controller provides several enhanced features that helps optimize efficiency and increase longevity of the overall system. Let's talk about system efficiency. In instances when the inverter is called to run at low output power, the inverter efficiency drops drastically when running below 20%. However, in a system with several LS-BRic inverters, when running at low output power, the master controller will maintain each LS-BRic at the optimized level of output by changing the number of LS-BRics that are actually running. Let's talk about longevity. In instances when the system doesn't need to run at 100%, the LS-BRic master controller intelligently cycles LS-BRic inverters in and out of service. Rather than running all the inverters at a reduced power output, it may take one inverter out of service completely and distribute power amongst the remaining inverters. The LS master controller tracks the accumulated power output of each inverter and selects which inverter to take out of service to optimize system's lifespan. Here is just a quick overview of the inverter specifications. It comes in 3 different AC voltage ranges, all of which can operate up to 1,500 volts DC. They can be paralleled with up to 16 units, providing a maximum of 3.2 MVA.